Okay, so today I'm going to be doing homework 2, part B. Using a force balance on a rectangular prism, demonstrate that the buoyant force is equal to the weight of the fluid displaced. Explain how this extends to an arbitrarily shaped object, like a human body. Okay, so first, we are going to consider a rectangular prism. Okay, so we have our rectangular prism. We have our length L, we have our width W, and then our height is H, and we're gonna pretend like this is submerged in some fluid, density rho. Okay, the fluid's water, but density rho. Because of our water being, like our object being submerged in the fluid, there's pressure happening on all sides of it, like pressure happening from everywhere, pushing against the rectangle. And one thing is that fluid pressure increases with depth, so the pressure on the top and the bottom are different because of that. Our depth equals y, because this is going to change depending on the top and bottom of the prism. With this, we know that P is going to equal PO, which is the atmospheric pressure, plus PGY. So we have our gravity, and then we have our depth. Okay, so now we're going to be looking at our top surface. So we're going to have a different pressure, like I said, at the bottom. So looking at that, we're going to have P top equal PO plus PGY top. And now we need to take in consideration area because of the pressure from the water. So when we take in consideration area, we have the force top equals P top times area equal to this. They're going to equal each other. Okay, they're going to equal each other, but that's not all. It's going to be PO plus PGY, and then we're going to have width times length, because we need the rest of the area, well, volume. And then we have the bottom surface located at Y bottom because of depth. Y bottom equals Y top plus Y. So P bottom is going to be equal to P bottom times area, which is also set equal to PO plus PG Y top plus H, there's parentheses there, times length times width. It's PG Y top. Now, the buoyant force is the net upward due to different pressures. So we're going to have FB equal, which is F bottom, Restart. We didn't see it. So now we're going to have FB equal F bottom plus minus F top Y top plus H times WL minus PO plus PG Y times WL. That's Y. After expanding, canceling, and factoring, you end up with FB equals PGWLH. So pressure times gravity times the width times the length times the height. That's what we end up with. Now, the buoyant forces come from the difference in pressure, top plus bottom, of an object. This force is equal to the weight of the displaced fluid, regardless of the shape of an object. This explains why some objects sink and float like human bodies, like why they feel lighter in water. So this is our answer.